Hello, welcome back. And now we're going to start talking about set theory. And so we're going to start a discussion of set theory by introducing the idea of sets. It is natural for us to classify items into groups or sets and consider how those sets overlap with each other. We can use these sets to understand relationships between groups and analyze survey data. Here are the basics. An art collector might own a collection of paintings, while a music lover might keep a collection of CDs. Any collection of items can form a set. So by definition, a set is a collection of distinct objects called elements of the set. A set can be defined by describing the contents or by listing the elements of the set enclosed by curly brackets. So here is an example of some sets. Some examples of sets defined by describing the elements would be A, the elements of all even numbers, or B, the set of all books written about travel to Chile. Okay, some examples of sets that are defined by listing the elements are what? The following. A, we could have the set of 1, 3, 9, and 12, or we could have the set of colors red, orange, yellow, green, blue, indigo, and purple. Now notice that in both of these cases, they are enclosed by the curly brackets. So if they were not enclosed by curly brackets, we would not call these sets. They would just be a list of numbers or a list of colors in this case. Okay. Now order doesn't matter as well. If you have a set, it does not have to be in increasing or decreasing order. Any particular order is fine. A set simply specifies the contents. Order doesn't matter. The set represented by 1, 2, 3, right, in this case here, is the same set if represented by 3, 1, 2. It doesn't matter. So let's talk about notation. It says commonly we will use a variable to represent a set to make it easier to refer to the set later. We also use this symbol here, which looks like a strange looking E. This means is an element of. Okay, so if we said 3 is an element of S, then we're saying, hey, whatever the set is S, 3 is in there. Okay, the set that has no elements in it is called the empty set and is denoted by the pair of curly brackets with nothing between them except the space, and also notated by this symbol here, which is like a 0 or O with a slash through it. So let's look at an example here. So let A, so notice we have A, we're defining A as a set of numbers, 1, 2, 3, 4. Okay, so there are only 4 elements in the set A. To notate that 2 is an element of the set, we would say this, right? So 2 followed by the symbol for is an element of A. Okay? Sometimes a collection might not contain all the elements of a set. For example, Chris owns 3 Madonna albums. While Chris's collection is a set, we can only say that it is a subset of the larger set of all Madonna albums. Okay, so what is a subset? Well, a subset is a set of elements, right? It is a set of elements, but it's also a set contained in another set. So a subset of a set A is another set that contains only elements from set A, but may not contain all of the elements of A. Okay, so if B is a subset of A, we would write this symbol here. Okay, that is the symbol for subset. Okay, so that means if we say B is a subset of A, that's what we would write. And now, also realize that in this case, it is okay if B and A are the same, if they're equal to each other, if they have the same elements, that would still be a subset. Now, a proper subset, though, is different. A proper subset is a subset that is not identical to the original set. So that means it cannot be equal to. So it contains fewer elements. Okay, so if B is a proper subset of A, then we would write this symbol. We would use this symbol. Okay, so notice it doesn't have the underscore or the, if you will, equal sign. Okay, so let's look at example B. Or excuse me, I'm sorry, example 3. It says, consider the two sets A, or 3 sets, A, B, and C. So A is the set of all even numbers. B is the set of the 3 numbers 2, 4, 6. And C is the set containing the elements 2, 3, 4, and 6. Now here, B is a proper subset of A. Why? Because every element of B is also an element of A, but they're definitely not equal. Okay, so B is definitely smaller than A. It's contained inside of A, so it is a proper subset. More formally, we would say, obviously, we would use the symbolism here. Since if X is an element of B, then it must be true that X is an element of A. Okay. It is also true that B is a proper subset of C because C contains the elements 2, 4, and 6, which are also in B, but it also contains the extra element 3, which is not contained in B. So B is a proper subset of A, or excuse me, of C. But C is not a subset of A. Why? Because C contains the element 3, which is not contained in A. Okay, so it can't be a subset of A. Okay, so let's look at example 4. Suppose a set contains the plays Much Ado About Nothing, Macbeth, and A Midsummer's Night Dream. What is a larger set that it might be a subset of? Well, if we look at this, these are all plays by Shakespeare. These are all Shakespearean plays. So all we would need to do is come up with a set with more Shakespearean plays. Okay? So this obviously is a set of Shakespearean plays, but it is not the entire set, so it is a subset. Okay? In fact, it's a proper subset. It would also be a subset of all British literature, if you wanted to be more general. Okay, so now let's look at this triad. So we have set A, which contains the numbers 1, 3, and 5. And it says, okay, what is a larger set this might be a subset of? Well, we could say B, or well, let's say O. O is the set of all odd numbers. Okay, or we could say it's a subset of the set B, where B is 1, 3, 5, and 7. Okay. All right. We'll stop there.